Hello and welcome to StarMade. They changed the chat interface, but that's not what I'm here to talk about today. Today I'm here to talk about power generation. So first of all, I'm going to start off with a single, well, first of all, there's this interesting glitch I've noticed where when you start with no power, you have 0 energy a second, but if you put a block down, you get 140.8, but if you remove the block, you get 1 per second. So adding a block and removing it gives you power inexplicably. But ignoring that for the moment, you place a single block, you get 140.8 E per second. So how do you get more power? And furthermore, how do you get it efficiently? Now you might think right away to just build like a 3x3 cube like this, maybe. And this will actually generate you 1429.24, excuse me, 0.9. Now if you'd used separate blocks instead, like every single one of these completely separated from the rest of the cube, you would actually have 3801.6, which is quite a bit more actually. So it's not an efficient design at all to make a cube. Another design that you might think efficient if you've played StarMade before is something like this, because if you know, StarMade bases things on dimensions, so how many in X, how many in Y, and how many in Z. You might think that's more efficient. And actually, that's wrong, because this is too small to be efficient. As you can see, if I just have one of these lines in here, like this, 924.9, if those were all separate, we'd be generating 985.6. So it's a very small difference at this point, but it is still a difference. Now, if we jump it up to 4, like this, you'll see we're generating 1472.9 per second. And if these were all separate, we'd be generating 1408. So it's a very small difference, but we've crossed the threshold into more efficient than them being completely separated like this. So see how that's 1408.4, but when they're all together in that original configuration, that's actually more efficient. So basically, your goal is not to build any kind of flat planes or three-dimensional structures like this. Your goal is to create things with several dimensional lines, like just going off in a line like this. And the more of these you have, the better. And if you have too few, well, they're not any good. When it's three-dimensional, the minimum you have to have in each direction, assuming we're just, using square dimensions, you have to have at least 4 blocks to be efficient in 3 dimensions. And if you're just doing 2 dimensions, though, you have to have at least 5 blocks to break over the efficiency of just having single blocks. Another quick little thing is that if you have 2 blocks side by side, you make 238.9. But if you have them separate, you make 281.7. So it's actually more efficient when you have very small numbers of power reactors to break them apart. Oh yes, that brings me back to the different dimensions. So like I said, if you're going 3 dimensions, you need at least 4 in each dimension. If you're using 1 dimension, however, you have to go all the way up to 9 blocks in a row to start being more efficient than just having them on their own. Of course, the moment you branch out into a second dimension, that starts getting even better. So basically the gist of this is, if you have very small things going on, it's best to keep them separate. If you have very large things going on, or even medium things, then it's best to join them together. Also, keep in mind that with structures like this is a 5x5 kind of area that I'm taking up, well, I can easily, in the exact amount of space, set up separate efficient reactors. And so you can see I'm doing that now, so now we have 2 completely separate reactors that are both efficient running in the same space. I'm going to add a 3rd one in here, and I'm pretty sure you could find ways to make more. If you actually look up 5x5 reactors, people have spent a great deal of time generating the most efficient configurations of 5x5 reactors, fitting as many things into a tight space such as this as possible. Also, an important thing to note, let's build a structure like this, okay? It's very simple design, like I was just saying. That is actually the exact same efficiency as if I had built it like this. because it only cares about the dimensions. If you look at this, we have the same number of boxes as well. Actually, I have one more on this side because I started down here. So 1, 1, 2, 2, 3, 3. This is the fourth one. That's the fourth one. This is the fifth one. That's the fifth one. 6, 6, 7, 7, 8, 8, 9, 9, 10. I've done something wrong in my calculations here. I'm counting wrong or something. 3, 6, 7, 8, 9, 10, 3, 4, 5, 6, 7, 8, 9. Oh, I know what I did wrong. There. Now they're the exact same thing, and they're same number of blocks, like I said. Same efficiency, same number of blocks, look different. And so you can actually do really creative things. Like, for instance, if I went over to the SS Nomnoms and showed you its internal reactor structure, you would see that I've basically lined the inner hole in some places with structures like this of reactors. In fact, I'm going to go ahead and go show that to you. I'm going to use this ship over here because it's super fast to get over there. Also here, take a quick look at this. This is actually a spreadsheet that I made to quickly design things and figure out what the actual exact values were, because I had to check for myself. And I forget if I already said it, but this is the Javelin, and as you can see, it is super, very fast and a bit twitchy. And I think I just barely bumped into the SS Nomnoms and sent it moving. But that's okay, because now we can stop it, and I can go inside to show you. Here we go. So we actually have two separate reactors here. See how this one, it goes down as far as it can. It actually goes around to the wall right there. It's kind of hard to see, but it goes around there, and it goes all the way through up here to somewhere up here where it stops. And when you go this way, it goes all the way up over and around to here and to this bit and comes back down the side. Now, it might actually be more efficient to have one reactor line going here, connect to this side, and disconnect this middle bit entirely, and then do the same thing on the other side, so you have two separate reactors going on each side. That probably would actually be more efficient, but I've done it like this, so that if one side gets disconnected, notice how there was only a very, very small drop in power just now. When I disconnected, I split a reactor basically in half, but we only had a very, very tiny drop in power generation. And it's the same thing with this structure. It looks a bit different, but it's still set up using that same idea of the most efficient. It's not the most efficient because we got this weird little, we got like two things duplicating the same kind of motion on the dimensions, but overall it is still fairly efficient. It is still very efficient, and if parts of it are disconnected, it can still run almost as well. Like, see, I'll disconnect another bit, and you notice the power didn't drop by all that much, even though we took out a significant chunk of the reactor. There's also another bit here. I forget what this connects to. It might connect to the same as the original one, meaning it's more redundancy in that we can, yeah, see? Look how little that chopped off. So, yeah. Redundancy is the key, but it is less efficient. So it's not really the key, unless you're in combat, or are otherwise damaged. Which, this is a salvaging ship, so it really shouldn't be in combat anyhow. But that's all for now. Thanks for watching, as always. See you in space, whether it be in Kerbal Space Program, StarMade, or anything else, really. Goodbye.